So this next portion of our examples look really simple, but are actually a little bit more challenging. So I start with our blue chart of exact values. We're going to use this very heavily. And I also have a little unit circle with all of our exact value angles. So all of the red angles are 30-degree reference angles. So we know that this first chart column here, this would be the red angles down below. Our second column is 45, 45, 90. So this would be the blue angles on the chart. And then our third one is 60 degrees, and those are all of our green angles down below. And then we know the exact values of the black axis values. So any of these angles are what we are working with for our next set of questions. So these are going to be helpful. I'm going to do a quick pickup of these because I think it's going to help us. So I'm going to copy this and bring it down into our first example. So here's what we're working with. It says evaluate using sum and difference identities, and we want to leave our answer as an exact value. So we're going to use these, and we're also going to use our orange square of sum and difference formula. So I'll grab that when we need it. So the first thing I want to do is 75. 75 is not an angle I know if you look over here. So can I rewrite 75 as two of these angles that I do know? It could be a sum, it could be a difference. And right away, I see that 30 degrees and 45 degrees add up to 70. So, or 75, excuse me. I don't know 75 exact value, but I do know 30 and I do know 45. And so I'm able to do a combination of these exact values I know and the orange box. So I don't have the orange box here and I'm not going to take time to find it. I'm going to expand this out. I can't distribute, but I can expand. Our formula for sine of A plus B, I'm going to write it up here since I don't have the box next to me. Sine of A plus B is sine A cos B plus cos A sine B. So in our question, A is 30 and B is 45. So we're doing sine of 30 cosine 45 plus cosine of 30 sine 45. So that's using the orange box to expand out the sine of 75 as the sine of 30 plus 45. Now I'm going to go over here to my blue box. The sine of 30 is 1/2. The cosine of 45 is radical 2 over 2. The cosine of 30 is radical 3 over 2. And the sine of 45 is radical 2 over 2. So that gives me radical 2 over 4 plus radical 6 over 4, which means the sine of 75 degrees is radical 2 plus radical 6 over 4. Now, the benefit of this is that you have an exact value. You know we love exact values in the math world. So if I just typed sine 75 into my calculator, I'm not going to get this expression. It's irrational. Your calculator won't give that to you. So the benefit here is we get a nice exact value for our angle. Okay, our next example, same idea. We want to get an exact value for the cosine of 11 pi over 12. So I'm going to start here because I think it's really hard. 11 pi over 12. I'm just going to do a quick conversion. I'm going to multiply by 180 over pi. Pi's cancel. I get 11 times 180 is 1980 divided by 12, and I get 165 degrees. So really what we're working with here is cosine 165. Now again, 165, it's not one of my angles that I have in this little unit circle here. So can I come up with two angles that would add or subtract from each other to get to 165? So the first thing I think of myself is 120 degrees and 45 degrees. So 120 is right here. It's a green angle, and 45 is a blue angle. So we know both of those angles. So I'm going to rewrite this as the cosine of 120 plus 45 degrees. They're equivalent statements. The benefit of 120 and 45 is those are values that have exact value reference angles that I can find. So I'm going to then use cosine of A plus B. So here's cosine A plus B. I'm going to circle it up for us. It's cosine A, cosine B. So we're going to say cosine 120, cosine 45, minus sine 120, sine 45. So my addition subtraction, it's opposite what it was in the parentheses. Now I'm going to evaluate. Now some of these are easy. Cosine and sine of 45 is easy. That's just radical 2 over 2, radical 2 over 2. Now, cosine of 120 and sine of 120. 120 is green. That means it has a reference angle that's 60 degrees. Cosine in the second quadrant where 120 in is going to be negative. So this is going to equal, I'm going to write this out, negative cosine 60 because of its quadrant, minus sine of 120. Sine is going to be positive in the second quadrant, so it's going to be sine of 60. So now I can go to my chart. 60 is pi over 3, so sine of 60 is radical 3 over 2, so this should be a minus radical 3 over 2 times radical 2 over 2. Cosine of 60 is negative 1/2 here. Let's move that down so it's a little bit more in line with the other stuff. And then we know this is a radical 2 over 2. And then I just evaluate. This is negative radical 2 over 4. This is minus radical 6 over 4, which means cosine of 11 pi over 12 is negative radical 2 minus radical 6 over 4. Now you'll notice that that answer is super similar to what we had previously in example 4, and that's really common for those to be very similar because you're working with all the same kind of players in this game. Our last question like this is tangent of negative 15 degrees. It's a little bit different because it's negative. That just means that we can do a subtraction instead of an addition. I'm going to do real obvious. There's lots of different options here, but I want to rewrite negative 15 as two values that I know. And the easy ones for me is 30 minus 45 degrees. You could also do 45 minus 60 degrees would work. So I'm picking two values from the angles within this wheel here that I know exact values of that would give me negative 15. So now tangent A minus B. Tangent A minus B is the very bottom property there. So this is going to equal tangent of A, which is 30 degrees, minus tangent of B, which is 45 degrees, all over 1 plus tan 30 tan 45. So we're expanding this out. Remember I said at the very beginning of our notes here, the questions that look complicated are very simple and easy to do. The ones that look easy are much more complicated. So we're using tangent. Here's my tangent row of exact values. I want tangent of 30, which is radical 3 over 3, minus tangent of 45, which is 1. And so when I clean this up a little bit, radical 3 over 3 minus 1, all over 1 plus radical 3 over 3. I'm going to multiply everything by 3, top and bottom. That's just to get rid of the complex fraction. And I get radical 3 minus 3 all over 3 plus radical 3. Now that'd be great to leave that, but it's not a simplified answer. So the last thing we need to do here is we need to get rid of the radical on the bottom. So I'm going to do 3 minus radical 3, top and bottom. On the top, we get 3 root 3 minus 3 minus 9 plus 3 root 3 all over 9 minus 3 root 3 plus 3 root 3 minus 3. So when I put it all together, 6 root 3 minus 12, all over, middles cancel, all over 6. So root 3 minus 2. So the tangent of negative 15 degrees is root 3 minus 2.